In the early 1950s, the first jet aircraft began flying in Europe. The infamous de Havilland Comet and the Tupolev T-104 had taken the industry by storm, and the United States knew they needed to play catch-up. Welcome back to A Brief History, a series where I take a short but deep dive into the most influential airlines and airliners in aviation history. In today's episode, we're covering the Douglas DC-8. Before we get into this video, I want to take a moment and shout out my new golf podcast called Mull It Over. I know a lot of aviation fans also enjoy the golf, so go check it out. The DC-8 story begins much like that of many jet airliners of the time. Pressure from airlines. In 1952, American Airlines chief executive and longtime friend of Donald Douglas Sr., Richard G. Hubler, pressured the aircraft maker into making a long-range version of the DC-6. Donald Sr., however, was not sold on jetliners for commercial transport, so he pressured management to develop the DC-7. At the time, Douglas was looking at developing a jet tanker for the Air Force, and they had looked into a jet for passengers, but the DC-7 diverted all of their resources away from a passenger jet. Meanwhile, over at Boeing, President Bill Allen had secured the U.S. Air Force's tanker order with a $16 million jet prototype. However, Douglas's upper management was not sold on the fact that the U.S. Air Force would only buy a tanker from one aircraft manufacturer. In February of 1945, in astonishment to many at Douglas, the U.S. Air Force placed an order for 21 of Boeing's KC-135 mid-air refuelers, even though their technical evaluations were not yet complete. Despite the order, Don Douglas stated that 1954 was the finest year in the history of the company, and partially due to their financial stability, gave the green light to begin development of the DC-8. The design was finalized on June 7, 1955, and development costs were slated to be around $450 million. The original variant of the aircraft would be powered by four Pratt & Whitney JT3C engines. The range was slated to be around 3,700 nautical miles and would be able to carry 125 passengers. The leaders of the Douglas Company assumed that they would be the first to crack the commercial jet market, with Lockheed focused on their Electra and Boeing tied up in their KC-135 program. But of course, Boeing had other plans. The first airline to announce its intention to order the DC-8 wasn't Pan Am, as is often claimed, but National Airlines. In August 1955, the Miami-based carrier declared its order for 6 of Douglas's new jets. However, the order that truly made waves came on October 13th when Pan Am made aviation history by committing to 25 DC-8s alongside 20 Boeing 707s. Just weeks later, Douglas pulled off a bold move. After the IATA annual meeting in New York, company president Don Douglas invited executives from 20 major airlines to Santa Monica for a special announcement. With United Airlines' Pat Patterson by his side, Douglas revealed a landmark order. United had committed to 30 DC-8s. This was a direct response to Boeing's refusal to widen the 707's fuselage to a 6-abreast layout. For a moment, it seemed like Douglas had the upper hand. But that moment wouldn't last. The next major airline to place an order was American Airlines, led by Cyrus Smith, a longtime supporter of Douglas. Smith had previously convinced Douglas to delay jet development in favor of the DC-7, but when it came time to choose between the DC-8 and 707, he went with Boeing. The reason? Boeing already had a jet flying. American's Assistant VP of Equipment Research, Dan Beard, later explained that the 707 had a significant advantage. It was built on lessons learned from Boeing's previous jet designs, including the B-47, B-52, and the 367-80 prototype. Cost also played a role. Because of Boeing's military contracts, the 707 came in at about $500,000, roughly 10% cheaper than the DC-8. But what really sealed the deal for American was Boeing's decision to widen the 707's fuselage by 10 inches, bringing it in line with the DC-8's cabin width. American engineers also had concerns about the DC-8's wing. With a 30-degree sweep compared to the 707's 35 degrees, the DC-8 was inherently slower, by about 20 miles an hour. Speed was everything in the 60s, and American doubled down on the philosophy by later ordering the Convair 990, which promised even higher speeds. Their plan? Fly first-class passengers on the faster Convair, while economy passengers traveled on the slower 707. In the end, the DC-8's wing design became a major drawback, but it wasn't the only challenge. According to Harold Adams, the program's management relied too much on blind faith, a strategy that had worked in the past for Douglas but fell short this time around. The DC 8 was still an impressive aircraft, but it was clear that Boeing had taken the lead in the early jet age. The DC 8 made its first flight on May 30th, 1958, in front of a crowd of 95,000 Douglas employees and guests. But excitement quickly turned to concern when unexpected aerodynamic issues surfaced. The aircraft's drag was much higher than anticipated, 13% over estimates and 10% beyond what Douglas had promised. Both the wing design and engine placement were causing problems. Performance was another issue. Early models, equipped with the Pratt & Whitney JT3C turbojets, fell short of expectations. Instead of reaching a cruise speed of Mach 0.84, they struggled at Mach 0.798, well below the guarantee. Douglas engineers got to work on solutions, adding wing slots, extending wingtips, and reshaping the leading edge of the wing. However, with production already in full swing, making major design changes wasn't easy. The most critical fix? Reprofiling the wing's leading edge wouldn't be incorporated into the new aircraft until the 148th unit. Earlier models could be modified, but it wasn't a simple process. While these updates improved performance, they didn't completely solve the problem. To keep airline customers satisfied, Douglas offered a financial settlement, $230,000 per aircraft. That did help smooth things over, but it didn't fix the range limitation that plagued the DC-8. Still, Douglas reassured airlines they were committed to improving the aircraft, and this promise helped maintain orders. Between 1958 and 1965, Douglas introduced several different DC-8 variants, each with tweaks to improve performance. However, this constant revision stretched engineering resources thin. The real breakthrough came in 1960 when Douglas announced the DC-8 would be upgraded with the new Pratt & Whitney JT3D turbofan engine. With much better fuel efficiency and power, the engine would finally give the DC-8 the performance boost it needed. Behind the scenes, though, not everyone at Douglas believed the DC-8 program was worth saving. Years later, Don Douglas Jr. revealed that some within the company thought they should cut their losses and leave the commercial aircraft business altogether. But he and VP Bob McGowan were determined to press on, with full support from Don Douglas Sr. After Don Jr. became president of Douglas in 1957, a major leadership shakeup followed. Over the next 5 years, 10 vice presidents either resigned or were let go in what Fortune magazine later dubbed the bloodbath at Santa Monica. In 1961, Don Jr. made it official. The DC-8 program would continue. At the same time, he restructured company leadership, placing McGowan in charge of the aircraft division and Charles Abel in charge of missiles and space. Meanwhile, Pratt & Whitney had already been working on converting the JT3C turbojet into a more efficient turbofan, the JT3D. The engine offered a significant boost in takeoff power and range, solving two of the DC-8's biggest weaknesses. Then, on December 20th, 1960, the first DC-8 equipped with the JT3D engines took flight. This marked the debut of the DC-8-50 series, a version that finally gave Douglas a fighting chance against Boeing's 707. In the early 1960s, Douglas began exploring the idea of stretching the DC-8. Thanks to its uniform fuselage design, this modification was relatively straightforward. By April of '65, the company officially announced 3 new extended models, known as the Super Sixties. At the time, the DC-8 program was struggling with fewer than 300 aircraft sold and the possibility of production ending. However, the introduction of the Super Sixties revitalized the program. By the time the DC-8 production wrapped up in 1972, Douglas had delivered 262 Super 60 models, nearly half of all DC-8s ever built. Among these, the DC-8-61 and the DC-8-63 stood out for their high capacity. Seating up to 269 passengers, they were the largest commercial jets available until the Boeing 747 entered service in 1970. Meanwhile, the DC-8-62 had a shorter fuselage but was designed for long-haul, non-stop operations, making it an appealing choice for airliners needing extended range. Like all early jetliners, the DC-8 was noisy compared to modern aircraft. As air traffic increased and public concern over noise pollution grew, calls for stricter regulations followed. By 1966, even before the DC-8-61 had flown, the Port Authority of New York and New Jersey voiced concerns over its noise level. By the early 1970s, many countries had begun enforcing new aircraft noise regulations, and the DC-8 Super 60s faced the threat of being banned from major airports. In response to rising pressure, several airlines approached McDonnell Douglas in the early 1970s requesting quieter engine modifications for their DC-8s. While third party companies developed aftermarket hush kits, Douglas initially showed little interest in offering a factory backed solution. That changed in 1975 when General Electric began discussions with airlines about equipping both the DC-8 and 707 with its new CFM 56 turbofan engine. Although McDonnell Douglas was hesitant at first, the company eventually backed the project in the late 1970s, leading to the development of the DC-8 Series 70. The DC-8 71, 72, and 73 were direct conversions of the 61, 62, and 63, with the primary upgrade being the replacement of their JT3D engines with the more fuel-efficient CFM 56 turbofans. These high bypass engines delivered 22,000 pounds of thrust, improving efficiency and reducing noise. This conversion process also included new engine nacelles and pylons, which were designed and built by Grumman Aerospace. While the aircraft retained their original maximum takeoff weights, the added weight of the engines resulted in a slight reduction in payload capacity. The modifications required for the 71 were more complex for those of the 72 and the 73, since the 61 lacked the improved wings and relocated engines found on the 62 and 63. All three updated models received certification in 1982, and by the time the conversion program ended in 1988, a total of 110 Super 60 DC-8s had been upgraded. As of January 2025, only two DC-8s remain in commercial service, both operated by the Congolese cargo airline Transair Cargo. These aircraft, registered as 9SAJG and 9SAJO, are DC-8 62 models. In the United States, the DC-8 has been fully retired from commercial operations, with only one remaining on the active registry. Samaritan's Purse, a humanitarian relief organization, has operated a DC-8 72 Combi since 2015, having it acquired from Air Transport International. NASA retired its long-serving DC-8 72 Flying Laboratory N817NA in 2024. Since 1986, the aircraft had played a vital role in scientific research, contributing to studies in meteorology, oceanography, and geography. It's set to be replaced by a more modern and fuel-efficient Boeing 777-200ER. Following its retirement, NASA donated the DC-8 to Idaho State University, where it's now preserved at their regional airport. Although the DC-8 was not as popular as the Boeing 707, the competition fueled a bitter rivalry between Boeing and Douglas, eventually leading to major innovations within the aviation industry. Though its time in commercial service is nearly over, the DC-8's impact lives on. It helped shape the jet age, pushed engineering advancements, and set the stage for the aircraft that followed. If you enjoyed this edition of A Brief History, be sure to like, subscribe, and hit the bell so you don't miss the next episode. Thanks for watching, and I'll see you in the next one.